Assume you have 4 different experiments of bacteria that are growing or shrinking in a science classroom. So you have 4 different cultures. Some are growing, some are shrinking. How many days the experiment is going on is represented by T, and the number of bacteria in each experiment is F of T. Assume all of them are linear, and we're going to complete this whole entire table. So this right here, see the 1? This right here is all experiment 1 just presented to you in different ways. Row 2 is experiment 2. Row 3 is experiment 3, and I have a 4th that's below this you can't see. So what information is given for experiment 1, I don't give you the first 3 pieces of information. I only give you a sentence. You have to figure out the other pieces. So if we read this sentence, a bacteria started with 600 cells and is shrinking by 450 cells every day. So from that statement, hopefully you can make one of these to start with. Now for me, I read the sentence and I go, I think this is going to be the first step right here. I'm going to jump over here. Would you agree maybe that this would be a good spot to start, make the equation from the statement? And once I have the equation, could you then maybe make the graph or the table next, depending on what works better for you? Let's say you go from here to the table. Could we then use the table to make the graph? Or vice versa? It all depends on your feeling. You could go from here and go straight across. It all depends on what order you want to do it in. So, for this to go to an equation, do you understand I have a 650? Which is my beginning value? 600. So I started with 600, and am I growing or shrinking by this? Shrinking. So what this would look like is I would have a 600, and I'm shrinking by what? 50 T. Sorry for the handwriting. That would be my equation. I made an equation starting with 600, and I'm shrinking by 50 every time period for every day. From there, I need to choose to make the equation, the table, or the graph. I'm going to make the table. And to make the table, all I'm going to do is plug one value in at a time. So if I do f of 0, can I put 0 into the function? Or should you know what that is? Isn't that the y-intercept? Some of you could just see it, 600. Okay, then I could find f of 1. When I put in that, that'd be what that'd be? 600 minus 50 times 1. Oh, 50. Okay, let's do this. My great handwriting, 50 times 1. Does that work? That's pretty ugly, huh? C base that. So, are we okay? We plugged 1 into this equation right here. And what do you get when you compute that? Did you get 550? And does anybody just see the pattern? You could plug it in, or you can just perceive the answer. Aren't we decreasing by 50? Yeah. So if we decrease that by 50, won't it be 500? Okay. So I made an equation. From the equation, I made my table. From my table or my equation, could either of them help me with my graph? Now for my graph, I'm just going to go by ones down here. And remember, these are days. And going up, if 600 is my highest, I'm going to go by hundreds. Are you okay? I kind of skipped, but are you okay if I go by hundreds? I kind of put a couple key points. Is everybody okay there? 100, 200, 300, whatever you want to mark. Now, this is my graph. Could I just plot these 3 points? Or could I think of this and use this to plot it, depending on how your brain works best? I'm just going to use my table. I know my first value is 600. My next one at 1 is 550. And my number 2 is going to be 500. And then there it is. There would be my graph. All right, for experiment 2 here, we are given the table. From the table, we need to find the other 3 pieces. Now from the table, which one might be the easiest to do? I'd probably jump to the graph. From the table, that might be an easier way for you to start. So I'm going to start with the graph. From the graph, I could probably do either one of these next, depending on your situation. I'll probably go to here and do the sentence last. I think we'll go with that approach. So from the table, I'm going to jump to the graph. So on the table, it says at 0, I have 300. So if this is 1, 2, 3, and if 300 is my highest, well, let's use the same increments we had earlier. Can I put 200 and 400? Can I just go by the same measurements? Always go by all but ones on the time, and on this we're going to go hundreds on the number of bacteria. But for the first problem, is everybody okay at 0 we have 300? So at 0, can I put a dot at 300? And then next one, can I put this dot? At 1, can I put 330, or about as close as I can be? 330 is not going to be very accurate. I'm just going to kind of squeeze it in there. And then at 2, do I have 360? And then I have what? Next one's going to be 390. Okay, it's not very accurate, but it looks something like that. Again, I'm not asking for perfection on this, but you can at least see something. Is this bacteria growing or shrinking?
Growing.
Does the picture help you see that? Yeah, some of you could see it from the chart. They're growing. Now, some of you, in order to make the equation, do we know the y-intercept? Yeah. Can you guys see it's 300? We're adding something, but what's the rate of growth? So the rate of growth, can some of you look right here and see it?
Yeah.
Can some of you see it's 30? Now, if you can't see that, isn't the rate of growth the slope? So could you just take coordinates and find slope? If you're someone who needs to do that, that's totally cool. You just take the coordinates. You have one coordinate as 1. That's one coordinate. And the other one, I kind of put them backwards. But are you okay with those two coordinates? And can I find slope? We got m equals 330 minus 300 over 1 minus 0, and doesn't that give you 30 over 1, which is 30? So if you need to find slope, find slope. If you can just see it, you're cool. But can I put plus 30t there? So far, from this, we got a graph, now we made an equation. And isn't the equation easy to make a sentence from? We began with how much bacteria? 300, and we're growing or shrinking? Growing by 30 bacteria each day. So we started with 300. I probably should say started, but 300 bacteria. And we said growing by how much? 30 bacteria each day. All right, for this next problem, we're given the equation to start with. So if I'm given the equation, you can go anywhere here. What's next? I'm going to start with the sentence. Let's just make this in context. Do we know how much we started with from an equation?
100.
Yeah, don't we know we started with that?
Mm-hmm.
And are we increasing or decreasing?
Increasing by 30.
Increasing by
30.
30. So we put something like this. I started with how much? 100. I'll abbreviate bacteria. And we're increasing or decreasing?
Increasing.
We're increasing by 30 bacteria per day. Don't put it per month. Don't put it just by bacteria. By what units? Give me the units. So we started with 100 bacteria and increasing by 30 bacteria per day. Now, which one do we want to do next?
The graph.
It doesn't really matter. Whatever makes more sense. I just like this because it gives me context before I started. And it's really easy to go from an equation to the context. So let me think. I'm going to, this time, go from here. Let's just do the graph. Even though this might be easier, I'm going to go to the graph. So first of all, I've got to put my number. So 1, 2, 3. Let's go 200, 400, blah, blah, blah. Same increments. Now, according to the equation, don't we start at 100? And we're growing by 30. So if we go to 100, and we're growing by 30, well, over 1 would be a 30 more, wouldn't it be like right there? And we go by 30 more, wouldn't it be like right there? It goes 30 more. Do you see how we're kind of getting closer? Do you have a line that kind of looks like that? We started at 100, and we're growing by 30 each time. Something like that. It's not a perfect graph, especially because we're going by hundreds. It's kind of hard to fit it. But we got a basic idea. Now to make the table, the graph's not going to really help because we don't know the exact values, do we? How do we get the exact values for the table? Well, don't we start with 100? Instead of plugging numbers in, can we just think we start with 100, and what are we adding every time, according to the formula?
30.
Start with 100, are we adding 30 repeatedly? So if we add 30 to 100, what's this?
130.
Can you tell that'd be 130? And if we add 30 to that every day, what's the next one?
160.
Can you see it? Pretty easy table without even plugging values in. Once you have your beginning value, you just use your rate of change to get your future values. So now we have this one done. Now, for this last one, I'm given the graph. This is like benchmark 1.2, and with the rest. So from this graph, let's make the equation. Let's go straight down it. So for the equation, is everybody okay with I started with 500, and now the slope is a little bit harder. Okay, we started with 500 bacteria. Aren't we decreasing by?
Yeah.
Now can you make a little right triangle here to get slope?
Yeah.
And we do slope. Are you guys okay that m is going to be what? 100 over 4? So is that what? Now is that negative? It's going downhill. So that would be 25t. So we started with 500 and we're decreasing by 25 repeatedly. From there, I'm just going to go straight across. I could, jump over here, but I'm just going to make the table. Okay, if I go to the table, I started with 500, right? At 0. After 1 day, if I'm shrinking by 25, I have 500. I take away 25. Think of it money. A little bit easier with money. $4.75. No decimal, but money is such a nice way to compute numbers. I have 475 and I drop by 25. I'm now at 450, and so forth. Now for the word problem, well, look at the beginning. We started with what? Started with 500 bacteria, and we're decreasing, be careful on that one, by 25 bacteria per day. So, which bacteria are shrinking? Now, if you look at your chart, what you'll notice is, can you tell number 4 is going down from the graph? And if you pull this down, can you also see number 1 is going down? Isn't that easiest to look at the graphs? So is everybody okay with, I can just put 1 and 4? Would that be right? Okay, which bacteria are changing the fastest? Now, if I say it's fastest, could it shrink or grow? I don't care about which way it is. I just care about the digit. Which has the biggest rate? This is 25. This is 30. A 30 and a 50. So which is fastest? Is it number 1?
Yeah.
Even though it's a negative, is it still fastest? Ignore the negative, which is fastest, the 50. The negative is just telling you down, right? Direction. So what's the answer for that one? It'll be 1.
Yeah.
Which bacteria is changing the slowest? So which has the smallest rate? See here on the bottom, wasn't the one 25? So that would be number 4. Which bacteria has more after 10 days? Now, could we plug 10 into all 4 functions to know exactly? But just looking at it, which one will probably have more after 10 days? when I look at these, well, isn't number 1 and 4 shrinking?
Yeah.
So I don't think it's probably going to be between these two in the middle, right? And don't they have the same increasing rate?
Oh, okay.
Right? They're growing at the same rate. Won't this one for sure always be bigger than that one? So is it likely number 2 is going to be your best? To verify, could we plug in 10 to all 3? Yeah, you could plug in 10 to all 3 to make sure. But I have a good feeling that we said it's number 2. And which bacteria will die off first? Now, it'd be a dumb choice to choose 2 or 3 because they're not dying, they're growing. So I doubt they're going to die off first unless they all just spontaneously combust and die instantly. But are you okay? It has to be 1 or 4. Now, at a glance, yes, 4. Doesn't 4 have more?
Yeah.
Actually, no. Number 6 has more, right? But isn't it shrinking twice as fast? Is it a pretty good idea that number 1 is going to be faster? Shrink empty first because it's twice as fast? Even though this one does have less to start with, right? This one right here, it does have 100 less, but it's so much slower of a decay. I'm pretty sure by looking at it, it's 1. Now, could we plug numbers into both?
Yeah.
Could you see how when both ended with nothing and then compare? Yes. But you can also use logic and kind of a gut feeling.